Hello and welcome to lesson 7.3, applications of the dot product. Today we're going to see how to actually use the dot product to actually look at some word problems. So first off, the work when a force causing an object to move is measured in joules can be calculated using, so we usually use W for work, and we take the force F and we dot it with the force D. Or if you wish, since we do know that another possible calculation for dot product, the magnitude of the force times the magnitude of the direction times cosine theta. You should use the one with the cosine theta if you happen to know what the angle is. So let's take a look at this in the context of a problem. Please realize force is measured in newtons and displacement is measured usually in meters. Okay, so a 30 kilogram box is located 5 meters up a ramp, inclined at an angle of 15 degrees to the horizontal. Determine the work done by the force of gravity on the box. So in other words, how much information or how much energy is being produced by taking the box and pulling it down the ramp. So let's take a look here. So I'm going to make a ramp. I'm going to say this is an exaggerated 15 degrees. That's a lot bigger than 15 degrees. And I'm going to put a crate on here, or box. Doesn't matter which shape it is. Notice that gravity is pulling it downwards, like so. And that means the box is going to actually travel a distance 5 meters down the ramp. Well, remember that 9.8 newtons is approximately equal to 1 kilogram, so 30 kilograms times 9.8 turns out to be 294 newtons. Now the thing is, the angle actually in between these two vectors is not 15, based on the fact that this angle down here is 15 degrees and this is a right angle triangle. This angle is actually 75 degrees in between. So, using our dot product formula, because we have the angle angle theta in between, we should use this option. So our force is 294 newtons. Our distance is 5 meters. And our angle is cosine of 75 degrees. Plug that all in. Using our calculator, we get 380.5 joules, approximately, but not exactly. So work done is due to gravity is about 380.5 joules of energy. Okay. This one we saw yesterday, or when we talked about lesson 7.2. So, to find the angle in between two vectors, using our dot product formula, u dot v is equal to the magnitude of the vector u times the magnitude of the vector v times cosine theta. If you're remembering this, please pause this at this moment in time and try this out on your own. If not, then watch. Okay, so take the dot product between our two vectors. I'm going to work out the magnitude of each vector. And we're going to figure out theta. Okay, so this turns out to be 2 times 5, which is 10, minus 6 times 9, which is 54. It's going to be the square root of 4 plus 36. And this is going to be the square root of 25 plus 81. Work out cosine theta. Okay, so this is going to be negative 44 is equal to the square root of 40 times the square root of 106 to work out cosine theta. So rearranging, and now theta is going to equal cosine inverse of the value negative 44 over square root of 40 times square root of 106. So now I use my calculator. Because the angle, because this value is a negative right here, it should tell you that the angle is going to be bigger than 90 degrees. So this is approximately 133 degrees. So therefore, the angle between the vectors is about 133 degrees. And there we go. Okay, so another application of the dot product is used to understand how to project one vector onto another vector. So we're going to project the vector u onto v for this example right here. And I do apologize, this is supposed to say, this is vector u here. Okay, so just imagine that you have a light source that is perpendicular to v. That's shining down. So I'm going to draw a little light source here, a little light source here. As you can see, it's perpendicular to this vector v that we have down here. So if that happens, what it does is it takes a little shadow of u and makes it so that it's a vector with this arrow headed this direction. Or in this case, this one, this vector with this arrow headed in this direction. What these two new vectors are called projections. So this right here and this one right here is a projection of u onto v, which can be described as proj of u onto v or proj of u onto little v. Well, in order to figure this out, what we're going to do is we're actually going to come up with a formula for this. So work out the projection, projection of u onto v. Well, notice that it's in the same direction as the vector v. The only thing is, if the angle theta is going to be a positive, or the angle theta is either acute or obtuse. And if it's obtuse, we know that the direction actually turns out to be a negative value. So what we can do is we want a vector in the direction of v, so we're going to multiply it by the vector v, going to put it at the end there, and I'm going to multiply it by, because this piece right here is just u, the magnitude of u, times cos theta. However, realize that it's a lot bigger than that kind of vector. So, because it's the exact size of magnitude of u cos theta bigger, we're going to have to divide off the magnitude of v. So this is one possible formula that you can use. Some people prefer to actually multiply the top of the bottom by the magnitude of u times the magnitude of v cos theta, and therefore multiply the bottom also by the magnitude of v. So what you might notice is this top part turns out to be u dot v, and the bottom just turns out to be v dot v. And you just multiply them by the vector v. If you'd like to memorize this formula, you're more than welcome to. If you are going to be dealing with projections in the future, I suggest you actually memorize it. So let's take a look at how we can use this. So here we have the vector u is negative 6 and 7. So let me first draw that point. Negative 6 and positive 7 is right here. So I'm going to draw a line. There's my vector u. Now we're going to draw the vector v. So the vector v is given by negative 8 and negative 3. So I'm going to draw that line now. There's our vector v. So again, the projection of u onto v has it being perpendicular to the vector v. So perpendicular. And creating a projection in that direction. So this little blue vector right here is our projection. Okay, so let's work this out. Projection of u onto v is given by u dot v over v dot v times the vector v. Now realize the u dot v over v dot v is actually going to turn out to be a scalar. So when we work that out, it's going to work out to be a constant. So negative 6, comma 7, dotted with negative 8, negative 3, all over negative 8, negative 3, dotted with negative 8, negative 3, times it to the vector negative 8, negative 3. So let's work this out. This turns out to be 48 minus 21 over 64 plus 9. Multiplying that by the vector negative 8 and negative 3. So this is going to be 27 over 73 of the vector negative 8, negative 3. So it's smaller than the vector negative 8, negative 3, which we can actually physically see. Or if you want to write it, you can actually take the 27, multiply by the negative 8, get negative 216 over 73, and 27 times negative 3 is negative 81 over 73. And there you go, another way of writing it. And thus concludes this lesson.